Hey, everybody. Welcome to this Dust session for Builder number X. I don't even remember the number now. We'll be focusing today on reasoning and the new power of models, basically. We'll still wait for a minute or two. We've got about 60 people online. We might wait for a little bit more. So yeah, in about 2 minutes, I'll come back and we'll get started. Okay. Someone's getting some echo. Just let me know if anybody else is having it to see if it's on my side or not. And we'll get started. So the agenda of today is deep dive on reasoning, some use cases, a little talk from Stan about Dust and the future of AI agents. Cool, no echo from most people. Awesome, thank you. And a Q&A. Don't hesitate to ask any questions in the chat because it's going to be used at the end of the Q&A. As usual, also, you can join the Slack community. We'll send the link at the end of the webinar. This webinar is recorded, so you can skip if you need to do something else before the end of the hour, and you can always come back to the video later. All right, let's deep dive into it. Cool. So reasoning models, what is that? Just as a first little poll, if you're a Dust user, I would like to know if you have, there you go. If you have already used the reasoning feature on Dust, if you are happy with it, if you haven't seen a difference, or if you don't feel like you're prompting it correctly. Because we'll see that there's a small difference between how you prompt a non-reasoning model and how you prompt a reasoning model. So I see that most people haven't used it yet, so it might be a good thing that you guys are in this webinar right now. All right, cool. So just a small picture that basically shows the difference between a reasoning model and a non-reasoning model. The main difference is that the reasoning model is going to be thinking before answering. Models are a set of probabilities that are, it's a probabilistic answer. And the non-reasoning ones are just going to use their training to answer, and they might just go for an answer and might not always be the right one, but they won't ever reconsider it. Reasoning models are going to think before answering. So for example, in this question here, if a train is moving at 60 miles an hour and travels for 3 hours, how far does it go? It's a pretty easy question. So both are going to be answering correctly. But the first one, which is non-reasoning, is just going to answer 180 miles. The second one is going to answer, well, is going to try to understand why this distance should be calculated, how it should be calculated, and then answer through that, those calculations. And the main thing is that when you ask a pretty easy question like that, both are going to be right. But if you ask a more complex question, chances are that the non-reasoning model will be wrong and not realize that it would be wrong. While a reasoning model might be able to catch up on the fact that it could be wrong. So reasoning models are good at deductive and inductive reasoning. Deductive means that you deduct something like an actual fact. It's like a scientific fact. There's a a yes or no question, you know exactly the answer. Inductive reasoning is something more about, it could be that. It's more about thinking that something could happen this way or another way, but it's not exact rocket science, basically. And it's going to use chain of thought reasoning, so it's going to likely, depending on the model and depending on the UI that you're using on top of it, show you the way it's thinking. So, Caddy, to answer your question about additional cost for reasoning models, yes, they will charge you the tokens, the reasoning tokens. So you don't always see them, actually. And is it possible to teach reasoning models? I don't know what you mean by teaching. It's a pretty complicated word because it can mean a lot of things. But at Dust, for example, we teach reasoning models by giving them the right context at the right time, so they can answer and think about your context. So we could call that teaching. Okay, so they're also good at complex decision making, which is not great with the current state, well, the previous state of LLM, and but they're pretty bad at being fast. So if you want an interface where your customer, for example, will have an answer pretty fast, you don't want a reasoning model. And they're mostly bad at simple tasks as well. So they're programmed to think. So if you need them to just answer plainly something that's pretty easy, it's not the right way to go as well. So that's pretty much the same thing that I just explained. The main thing to understand is that this is the main new skill that they unlocked, is that they can use different approaches to validate what they're going through and try to find the right approach to keep going, which was not the case before at all. So if we need to compare them to coworkers, you can compare a regular regular model to a junior coworker. So you need to give them explicit instructions that will give a specific output, and always be as specific as you can so that the LLM can answer in the best way possible. If you've tried reasoning models, if you've tried O1, or if you've ticked that reasoning box on Dust and you manage to prompt it correctly so that the agent is actually using that reasoning capability, then you'll see that it's more like a senior coworker that you can give. You can just try to nudge them towards a goal, and they will figure out the details themselves. You don't have to be very, very specific. You just want to set some goals. You want to give them as many tools as they can to actually reach this goal, and then they'll go for it by just thinking. How does the model know it made the right decision given the correct response? Well, that's the thing, is that it's going to try it's going to iterate on the possibilities and then choose the right one. So basically, you could reach the same thing with the normal models, but you would have to keep prompting the model saying, are you sure, are you sure, maybe you need to figure out another way. And they'll end up figuring out the best way for the thing you asked. How can you extract the chain of thought after the response so we can log it? Well, that's a pretty technical question. Let's ask that either on the Slack community, because I don't want to go into API details right now. We're more on the high overview of the reasoning models, but you can extract it. And what about deep research? Because we've heard a lot about reasoning models, but we also heard a lot about deep research. Basically, deep research is just a set of tools on top of reasoning models. So they can browse the internet, they can synthesize information from a lot of different sources. They can actually start breaking complex questions. So that's why you can start asking things that you would have to prompt for like several dozens of lines before. Now you can just make a smaller prompt, and they'll be able to break it into smaller problems, subtopics, and then search for that subtopic specifically. and then gather all the information back and provide a comprehensive report from all the informations that they broke down. So at Dust, we actually do that, and we'll see an example right after that you might have seen in a video that we sent a few days ago in our product updates. But basically, in Dust, you can do deep research if you prompt your assistant correctly and your agent correctly. If you and if you create your agent the way we did in the example. To actually do that research on your internal data as well on external web sources. Okay, so let's see our example. First, I want to talk about the Model Context Protocol, which is a new protocol that Anthropic released a few weeks ago that basically allows, well, they describe it as a USB-C for AI applications. So they basically want to be the interface to add any applications to LLMs. So that's a pretty important thing for Dust because that's what we do, that's what we use every day. And so we're wondering what direction we should take when it comes to using that. And we used a little prompt for this to see if the LLMs could guide us in the right direction. And this is what a non-reasoning model would answer. So pretty short answer, 5 sources, just saying as a standardized protocol, there's 2 main things that you need to do. You need to use it being used as a client or being used as a server. You can use both of them, and we have some plans to do that. And the sources to use those plans are linked, and that's it. So we know we consider this a high priority, but there's not a lot of detail. There's not a lot of explanation or planning on what we should be doing and the actual plan, battle plan that we're using. Sorry, I'm just gonna add some of the questions to the Q&A at the end of the webinar. So sorry, I'm not answering directly, but I'll just flag them for answering at the end of the webinar. Cool. So this is a regular answer. So I asked the Dust agent, which is plugged to our entire data sources, like all of our data sources. So it went and gathered information from GitHub, from Notion, from Slack, and we built basically the same agent with reasoning capabilities and what we can call deep research, I would say. And this worked like that. So that's the answer of the non-research agent. That's a very small answer. And this is the answer of the exact same prompt, but on an agent that we called research. So here we can see that it starts with thinking a lot. That's a chain of thought tokens that you were talking about in the chat, and we are displaying it. We're displaying it so you can definitely extract it. So what it did is that it needs first to understand what MCP is, because I just asked, I need to understand everything about MCP. What is it? Why is it important? Why are we going? What are we going to do at Dust regarding this topic, and who's working on it? So it needs to understand what MCP is, then searching internal data about what we're doing at Dust regarding MCP, because that's what we're doing at Dust. You can search for internal data. Agents are really good at that. Then from the initial search, it will decide that it needs to be more specific, and it keeps going to do some more searches. And then it's searching our internal code base to get the implementation details of whatever we've been already doing. Still not happy with it, not enough information. So it's going to search for pull requests to know if we've discussed anything around that. And then trying to find more information about MCP itself, so doing a web search on top of it, etc., etc. So it's done a ton of research. You'll see that the answer is a lot longer, a lot more structured. So what is MCP? Why is MCP important? That's in general already 3 sources cited. Our implementation, so what we thought about first as an MCP server. So needing an MCP server was already mentioned by the first model without reasoning, but now it's telling us to do an MCP server and why, and all the implementation that that we need and that we've been thinking about. Then Dust as an MCP client. So the other side of the USB cable. Basically, you need both sides to work if you want the whole, well, basically the pipe to work. Then our current status, where we are, future plans around it, who's working on it, and why it matters. The main thing is that we've got 14 sources that were cited, so almost 3 times the number of sources that the non-reasoning model was using. And if we open the tools, we can see that there's a first search query, second search query, and then web navigation. It used a bunch of tools, and the main thing with that research agent that we built, so I can share the prompt at the end of the webinar. We have a pretty big prompt, and so we can definitely share it because it's really interesting to understand how the prompt was built, because there's not a lot of instructions themselves, like the info part and the instructions part are not that big, but the big part is the tools usage. So it gives the assistant all the information it needs about the tools that it can use. So it can take the decisions of actually using the tools or not. So you can search in a code base, search pull request, Google search, fetch web page content, internal data search, conversation data search, etc., etc. And then there's a small paragraph around deep research. So basically, we let this agent call itself. So in one of the tools that we have, one of the tools is called Research a Subtopic, and it's a desktop that's actually calling an agent that's doing the same job. So basically, there's a main agent. So if we look at that deep research part here, basically this agent is a lead research agent. It's going to direct other agents to search for them for some subtopics. And so we duplicated the agent, changed a bit the instructions, saying, okay, you're a sub agent and you can search for a subtopic, and then you will report that to your lead agent. And so basically what's happening there is that this agent is able to call up to, well, 8, I think, other agents, and then propagate and like consolidate the entire research for all the agents and give back a pretty thorough answer. That's what's happening behind deep research. And yeah, there we go. That's pretty much it. The rest, like, there's not a lot of instructions around actually giving a specific set of how the data should look like. It's basically what I said at the beginning. It's looking for a goal. Cécile, in the example you're detailing based on agents that you developed. So no, research is not available on Dust. It's something you have to build. Basically in Dust, you have access to either raw models or you have to build your agents. So I'll share the prompt at the end of the webinar, so you can use the prompt and you can build your own tools on top of it. But just to share you the few tools that we've been using, we've plugged our internal code base. We've plugged some of our pull requests from GitHub. We've plugged a bunch of internal data sources: Google Drive, Slack, GitHub, Notion. We've plugged what is this? Our Terraform and Helm infrastructure code base. We added some apps to be able to create SQL query guidelines, to download PDFs, to, well, the one that calls other agents, and we also have plugged our Snowflake database to be able to run SQL queries if necessary. So basically, yeah, you need to build your agent, but because, well, deep research per se will only search on the web, but on Dust it will search in your own data. So you have to define your own data. Yeah, we won't be able to just give you the agent that works as is. Can you switch on and off reasoning mode with the system prompts, and can we influence the reasoning time? So you won't be able to influence the reasoning time with a prompt because that's done only through the API, I believe. But you can definitely, with a prompt, say you need to reasonate to use reasoning or not. If you use 3.7. We did to call an agent from a Dust app. Basically, you need to call the Dust API through the Dust app to run a new conversation. Okay. Oh yeah, and so the big thing that we also ticked in the toolbox here is that reasoning box. An agent can decide to trigger a reasoning model for complex tasks. So we have set Claude 3.7 Sonnet on this agent, but you could also set any other model and let the agent decide to use reasoning by itself. I'll just try to add some of the questions again to the Q&A because it's pretty hard to follow the number of questions while talking. All right, yeah, so that's pretty much it for the use case at Dust itself. We're using it for a bunch of different things, but it's getting started and it's going to get a lot more powerful in the future. Let me come back to the slides. Oh, actually, that's the wrong slide. Well, that reasoning new capabilities are basically opening a new world for LLMs. They were notoriously bad at doing a bunch of things like math, for example. And so, well, actually, let me share a better slide because I forgot to add. There we go. Basically, it used to not be good at all at anything regarding math, anything regarding too much data. Basically, you needed to have as specific data as possible to be able to have specific answers. But now, because the LLMs or the reasoning models are actually able to correct themselves, which was not possible before, they can start analyzing a lot more data. So legal document analysis and precedent research becomes possible. So you can actually trust a lot more. I saw that there was a question around trust. You can trust a lot more the answer because they will be verifying their answer. I'm not saying it's going to be 100% right. It's not. It's still not an exact science because it's LLMs, but we're getting a lot closer to that number. So yeah, financial analysis, complex technical troubleshooting. Because before that, technical troubleshooting, if you were working on more than one file, or not using tools like Cursor or Dust, it was really complicated to have an LLM answer with your entire context. And now you can let them decide that they need to search for more info and browse your code base a lot more than they used to. Same thing for medical data sets. Validating data takes a lot of thinking, basically. Same thing for math. They were terrible at math, and now they can start trying to prove what they just said. So they will loop in and correct themselves until they're right. Oh, let me come back to that. Yeah, and so that's pretty much it for the reasoning dive. I'll let Stan talk about the future of agents at Dust. Hello, Stan.
Hey, thanks, Alban. Cool. I mean, I think it's a perfect segue. There's so much to be said about that research agent that describes probably the future and pinpoints exactly all the kind of product work we have to do to make it much more easier for us, for you to build those kind of agents. To step back a little bit, in January 2023. I'll let Alban maybe share his screen if he wants to, but I'll share the link here. So in January 2023, so it was 2 years ago, we hypothesized the existence of an uncanny valley for LLMs, and the idea is actually pretty simple. The idea is the following: is that as the level of abstractions or the complexity of the task augments, the level of reliability of models needs to augment as well for the humans to accept it. Basically, if the task is very fast to verify, it's okay if the model is not completely reliable, because it's very easy for you to verify the task. So if you have a task that takes you 1 second to verify and you get 60% reliability, you're really happy because maybe it saves you 2 or 3 minutes each time. And so for the 40% of times where it costs you a second to verify, you get a lot of value from the 60% of time where it saves you 2 or 3 minutes. But if the tasks become very complex, let's say it's a task that takes you 30 minutes to verify, and it's a task that would take you 2 or 3 hours to do, the same level of reliability is not acceptable, because there is no way you're going to spend 40% of the time, 30 minutes reviewing a task and just realize that it's completely bad and lose 30 minutes. And so we hypothesize the existence of that uncanny valley where, as the task gets harder and harder, the level of reliability would not match the complexity of the tasks. And I think that's basically what we're getting with reasoning models, is actually moving the needle of that uncanny valley, or almost getting out of that uncanny valley. When you step back, a reasoning model is really a model that exchanges cost for reliability. It doesn't mean that the model is necessarily way smarter than previous models. It's just that because it's expending much more compute at test time, it's seeking more, it's verifying its works, its level of reliability really augments for tasks that are somewhat hard. And so that means that for tasks that used to be not reliable enough because they were too hard, we're now reaching a whole set of tasks that become usable with models because those models have become much more reliable. And so if you remember, for the ones that were interested in that at the time, AutoGPT kind of really didn't work. It was roughly at the same time, 2022, 2023. AutoGPT was kind of a deep research model that would like trigger actions and try to achieve complex tasks. And it really didn't work at the time. And I think the reasoning models really brought something here and made that whole kind of, let's think for a long time, let's use many tools, let's verify what we get out of it, and let's try to get a pretty complex loop of interactions. They make it much more plausible today and usable, which is extremely exciting. And so what it means for us and for Dust and for you, it means that we're probably going to be using agents in a way where they're going to have much more tools, and they're going to have loops of interactions and runs that are much longer. And so I think that has impact on a couple of things that are important for us. And the first one is obviously actions. Today, when you want to add a new custom actions to a Dust agent, we do have support for that we call Dust apps. And they're not we do believe that they're not the best product. And so there's going to be a lot of work in the weeks to come on making it much more easier for us to add actions. And so I've seen in the discussion, like, how do we call an agent from an agent? It's an action that should totally exist today. It's just that it was kind of complex for us to add new actions. And so it was harder to get to get them quickly in, and the product was not ready to have all those diverse actions. And so that's something that we're going to work on, make it much easier for us to create new actions so that we can make available to you all those kind of very useful and generic actions. And also we're going to try to make it, and we're going to make it much more easier for you to add actions. Dust tabs were kind of useful, but we think we can do a much better job of enabling you to add actions to Dust. And probably on top of that, sharing, having the community create actions that can be shared across Workspace so that you can all benefit from each other. The goal here is really to go from having to create 5 different Dust tabs in a rather complex way to get to your research agent, to being able to create the research agent much more easily and with just a few clicks. And because there is indeed a lot of value, as we said in the conversation, if you've created sub-agents that are really good at searching some type of data, that's exactly a great fit for building a research agent on the top that would be able to call those sub-agents. So I think that work on action is a first big thing that we're going to be working on in the weeks to come. We mentioned during the talk the model context protocol. So basically, that's a protocol that is emerging for defining actions. And so we're going to try to build around that protocol because we believe it's a very fair and very good protocol for the future of bringing actions to models. And as was discussed in the presentation of the research agent results, Dust really position itself as both a client and a server. So I'm going to try to unpack that a little bit. So basically, an MCP server is a provider of tools to models. And so Dust will probably position itself we'll try to position ourselves as the greatest MCP server you'll have for anything that's any kind of a model that you use even outside of Dust, because you'll be building your company agents inside of Dust, and you're probably going to want in the future to be able to call those agents as tools from outside of Dust, and we think that the MCP protocol as an MCP server is a great medium for that. And then Dust will also be an MCP client. So an MCP client is in Dust to build agents, and you want to provide them with tools, and you want to extend the set of tools. And there's one way where we will consider Dust as an MCP client, because maybe you want to create an MCP action that is an MCP server on your infrastructure and connect it to Dust so that we can call directly into that. And we think that standardizing around that protocol will make that process much easier, because there'll probably going to be many ways to easily create MCP actions on your infrastructure in the future. And so following that protocol will make it much more easy for you to create them and connect them to Dust and make them available to agents in Dust, etc. So I think that's the first thing on the future of agents. Agents is all about actions, and we believe there is a lot of stuff that we can do, and we have a clear plan of actions there. And so what you should expect is see many more actions emerge inside of Dust, have the product change, especially in the builder, to be able to search and find all the actions that we have available for you. One type of obvious actions that you would want to probably add is, as we mentioned, calling another agent. It could be taking actions on platforms such as GitHub or Notion or Google Drive, etc., etc. When we think about agents and reasoning models, there's a second thing that I think is interesting to chat about. Basically, you know Dust, you're all builder of Dust, and so you know that Dust is pretty horizontal. And you see that there are also companies that are trying to tackle building AI assistants and agents in a more verticalized way. And so if you think about those verticals, and so Cursor is a great vertical. So Cursor is a very verticalized AI platform for developing code. And I think it's really interesting to think about those verticals because there's a lot to learn there. Basically, as the models are getting better, and that's exactly what's happening with those reasoning models, the level of abstractions of the tasks that the agents will be able to take is kind of moving up. And as that happens, we do believe that the verticals will probably have to go fetch some data outside of their verticals. So let me explain that. And taking the software engineering example, which I think is a great one, basically, if you think about a software engineer, a great software engineer is somebody that can code really well. And that is something that models can do almost as well, if not better than us. But a great software engineer is also somebody that has a lot of context on the company. It knows the design docs, it knows the preference of the company, it knows the coding rules, it knows the chatter in Slack, it knows what the sales people have been telling in their documents. It knows a whole lot of things that help him or her do their work in a way that is full of context. And so as the level of abstractions of tasks go up, let's say you have an issue in GitHub and you want Cursor or Devin to take it. Well, the information required for that task to be completed will require to go fetch some data inside of your company context, including Notion and Google Drive, and let's be crazy, even Salesforce and stuff like that. And so what we believe is that there's probably going to be more and more verticals that will try to get all of their verticals to get access to that context. Or it's going to be very hard for companies to manage having 20 tools or 20 SaaS products asking for permissions from 20 other SaaS products. And so, because you cannot have a quadratic relationship of permissions. And so we do believe it creates a really great opportunity to create, to have a layer that aggregates the context of the company, have a permissioning model that is compatible with agents, and make it available to all those tools. And so that's something we really try to build as well, is really try to be that layer that maps the data that you have within your company and enforce a permission model that is compatible with agents and make it available to people to build on top of that. So really want to see Dust also as a platform on which you're going to be able to build other apps that may live somewhere else, or maybe use other apps that need access to your company data. And so in a close future, something that we'll be super excited about would be that when using Cursor for developing, because you need access to your design docs and the Salesforce data and the support data, etc., you would do a connect with Dust inside of Cursor so that you would have access, Cursor would have access to your Dust agents that you maybe built to get information about support information or get information about your technical design documentation, etc. So that's the first thing. And finally, I think the third thing that is interesting to consider is probably, as you've seen we haven't seen live, but as you probably know, those agents with those deep loops and recursive loops of research, etc., takes a much longer time to execute. And so as we're going from 2024 to 2025, we're really going from the conversational interface where basically the interaction is with the human in the loop at all time. And so the amount of value you can get from agents is almost bounded by the capability of the humans to be in there interacting with it, to something where the agents might probably become much more autonomous and will require information from the human only at times and do a lot of work in between. And so we do believe that from an interaction and UI and UX point of view, there's probably going to be a shift from the conversation model to something that is much more like a command center where you run your agents and they ping you when they have questions and you can see who's working on what, etc. And so I think these are kind of the main three directions where we're really excited to work with you to explore what can be done. The first one is adding a whole lot more of actions inside of Dust and making it much more easier for you to do something like the research agent in the very near future. The second is really to build and position Dust as a provider of actions to the outside so that can build more AI stuff on top of Dust. And the third one is really exploring from an interaction perspective what it means to work with agents that take something like 30 minutes to operate, and if not an hour or 2 hours in the close future. So I think it was kind of an attempt at trying to describe you where we're going in terms of agents in 2025. And so excited to answer the questions you might have. Are you muted, Alban?
Yeah, I was just saying, let's look at the question. I guess the main one would be this. We've got 7 votes on this one. It's not really a question. We need an orchestration layer for the Dust assistants other than humans.
I'm not sure I get exactly the meaning of this one.
Alexander, do you want to say a little bit more about your question in the chat? We'll go through another one.
I think it really we need an extra layer for the systems other than humans. I think it really it kind of relates to what we just said. It's the shift from a conversation interface where it's really interrupt driven or it's question and answer driven to something that is much more of a command center. And I guess it relates to triggering agents in programmatic ways. It relates to having agents being run on top of schedules, or when even some events are happening, and also having agents being able to ping you when they need information instead of you looking after what's the state of the agents and the conversations. So what it means from a product perspective, it probably means two abstractions that we don't have today. It's obviously a way to trigger agents, so some sort of a scheduling layer. And the second thing is really having a notification center so that you have a central place to get information about what has happened and what has been run and what are the things that you haven't seen yet.
And Alexander, you're saying thinking of n8n and make.com for your agents. We have integrations for both, so don't hesitate to use them if you want to do that for now. But yeah, in the future, we'll definitely be able to do all that. All right, I think we already answered this one. Is there an additional cost for reasoning models token wise? Well, answer is yes. The using reasoning is usually a little bit more expensive because it consumes a lot of tokens. Maybe that's for you, Stan. Are we still limited by the maximum number of runs for the agent?
Yeah, so we've already bumped it, and we're trying to follow what we think are the best reasonable settings for the given state of models. We'll probably keep increasing it. As an example, I mean, it's fresh from last week. Sonnet 3.7 definitely has a tendency to use much more tools than previous models, and so we'll really try to look at same values there. What is sure is that when you haven't touched that value, we're able to update it for you. If you've touched it at some point, we don't necessarily have the freedom to update it for you. So I think it's something, as a builder, it's something that you want to keep in mind, is probably try to revisit that value for the agents you're in charge of. Try to bump it as we increase the limits.
I think we have now this. Do you have a rule of thumb to know when to switch from regular to a reasoning model? On the opposite rule of thumb, when not to overcomplexify with a reasoning model?
I think you want to the rule of the best rule of thumbs is to think what it would take to you as a human to complete a task. In many ways, those models are extremely anthropomorphic. The fact that they have to spit out tokens in plain English or whatever is the language to actually do thinking shows how similar to humans they are. And so whenever there's a task where you believe you would be able to do it by just looking at the information and answering, then you probably don't need a reasoning model. Whenever there's a task where you think you probably need to have a piece of paper next to you and a scratch pad where you can write a few things and maybe take a bit more of time thinking about it, is probably the kind of task where you would probably need to use a reasoning model.
What about the topic of training an LLM to perform a certain task, iterating of prompts with data and scoring, and going towards fine-tuning if prompting is not able to achieve a good score?
Yeah, here we obviously there are tasks where fine-tuning will provide value that is not achievable by prompting. They exist. Our position so far has been that while the models are evolving very rapidly, and we believe that's still the case, it would be extremely costly to us, to you, to our users, to try to achieve, to target fine-tuning. Basically, the first thing you have to understand is that fine-tuning is still a research project. It's still a research problem in a sense. It's still incredibly complicated. It's not something that you can, we don't believe it's something, or at least I don't believe it's something you can fully productize and make it a one-click solution. And so what we think is best for our users is to really stay away from that and instead really try to create the product that will make it as easy as possible to upgrade models as better models are coming. Basically, if you think about what was the state of models on some stuff, if only 6 months ago, the ability to take your agent that you had 6 months ago and switch it to Claude Sonnet 3.7 probably trumps entirely all the efforts you would ever have been capable of doing 6 months ago around fine-tuning on that tasks. And so we do believe that while the models are really evolving rapidly, it really has a lot of value to not even open the fine-tuning question at this stage. On the question of, maybe because I'm seeing on the chat, on the question of iterating on your prompts and fine-tuning in the sense of iterating on your assistants, we have a very opposite position, which is that it is a very high priority project and initiative for us to make the life of Builder much better there. Lately, we've released feedback, which is a first step towards having some form of quantitative and qualitative information about how your agent is performing. And we think there's much more to do there. And so that's something we'll be investing there. It's really important for builders to be able to understand the performance of the agents, iterate on their prompts, and see what's the impact.
In my company, Dust is loved because it's easy to use. In your vision, Dust will be a much more expert tool to use. Do you foresee a new job for agent builders in companies?
Yeah, I think it's true. I think we do want. So one thing that Dust is really good at is mostly what you wrote there, is that it's easy to, it's a tool that is easy to customize to your needs and get value out of. And I think that's been a main driver of our ability to grow inside of the teams we are working with, is that people can build their assistant and they can share the assistant or the agent they built. They can share their agent, and other people start using the agent, and some other people feel empowered of the Tinker, feel empowered of building agents, even if they're basic. And all of that really helps propagating the LM technology within teams. As we add more actions, as building agents become more and more complex, there's going to be an added complexity. I think it's going to be important for us to maintain a way to easily create the basic agents for everyone, and really have Dust be something where you can do the easy thing very easily and do the hard part with more involvement. But totally agreed that there might be a new job, agent builder. I mean, we've had the prompt engineer job title floating around for many years. Prompting is less so of a thing, not that the models are really well aligned, but I do think that a job of agent builder really makes sense. It's actually an idea that we're thinking about is for enterprise users. It's a fun idea. Maybe we'll do it, maybe we won't. But for enterprise users, is to have an agent board. And so an agent board it's like a job board. It's a place where people from the enterprise customer could say, oh, I want to have an agent to be able to do this, and I don't know how to do it. And that's something that we could help them and bring resources to help them build it. And that product can actually be supported by us, as it could be supported also internally by somebody that is in charge of building agents and could see that, oh, there are 10 teams in sales that need to build that thing, and it's been upvoted 10 times, and I know exactly where I can bring the most value to my company by building a new agent.
All right, I'm going back up in the questions a little bit. If I'm using Sonnet 3.7 and the reasoning is built in, is there a point of checking the reasoning option?
Yeah, it's a good one. So Sonnet 3.7 is trained to have kind of a flexible reasoning capability that is based on what the instructions are. And so it's a little bit at odds with the reasoning option that we added. And so I think the answer to that question is the jury still out, but you're definitely free to experiment. But it's possible that the answer to that question is indeed you don't need to check the reasoning option, because 3.7 is supposed to be able to adapt its reasoning tokens based on the context. And so the only thing that we can do is to really provide you with exactly what it means to check the reasoning option and what it means to use Sonnet 3.7. So Sonnet 3.7 really has that ability to, if it decides to think hard, to think harder, and so to expand more tokens, more reasoning tokens to get a better answer. And the reasoning option, what it is, it adds a tool to the main model saying, hey, if you have a question that seems to require hard thinking, instead of doing it yourself, call that tool and let that tool do the thinking. And that tool will call a reasoning model. And those reasoning model are either O3 Mini or O1 or DeepSeek R1. And so in a sense, the two definitely overlap. And I think the best thing, since we're 1 week in the existence of Sonnet 3.7, I think the only thing that we can all do is experiment there.
There was a question about making everything work with Zapier and Make because of timeouts. That's basically the issue of those two platforms, is that you can't really change the timeout setting. So that's why we're using a different platform called Pipedream, where you pay per the minute, so you can actually change that timeout. But I hope in the future Zapier and Make will align, because of LLMs are now changing the game on timeouts, definitely. I think that's pretty much it on the questions. Don't hesitate to ask more right now, or because the rest are very, very specific and a bit too deep dive. So let's talk about it in the community. There's maybe this one. As Dust is open source, where is the exact code for the reasoning deep search agent system?
Yeah, so you've seen it. It's not in the code because it's an agent that's been built, and the kind of core part of the agent is the sub agent that does a little bit of deep research, and that sub agent is a Dust app itself. So in a sense, the current at research agent that we presented doesn't live in the code base at this stage, but I think we are obviously very open to sharing exactly what the Dust app does and sharing exactly what are the instructions of that research agent so that we can reproduce it. We're obviously extremely conscious that it is not a fully productized version of this deep search of deep research. There's a lot that we can do there. There's a lot of product question, to be completely transparent. Is deep search an option on every agent, or is deep search a fully autonomous product that is not part of conversation? I think that these are all the questions we are working on right now to try to give you the best experience there. But what is I think a testimony to the extensibility of Dust is that with the necessary amount of work, even today, you can build a pretty solid deep research solution by using the existing agents and the Dust apps.
Do you do training sessions? Well, that's one of the training sessions that we're doing. We don't have official training sessions on like sitting with you to build your agent, unless you're an enterprise company, and for enterprise company we do some in-house training sessions. Damien, your structured outputs question, I guess, is, do we have structured outputs in Dust? Currently not exactly, but it's pretty much doable with either Dust apps or just good prompting. I don't know what you have to say about that, Stan.
Yeah, I think it feels to me like a structured output seems to be embedding a Dust agent inside of an external workflow. And so here we could do much better, but obviously you can use Dust Apps because Dust Apps will let you involve models, involve data sources, and do stuff, and eventually extract and return a structured output that is JSON available through the API. Obviously, we do understand that there would be it would be useful for some agents to be marked as structured outputs so that you could use them directly with the conversation API and all the integration we have in PyDream or Make or etc. Without having to think about it. And so that's kind of the current state of affairs. As the work, I think that's something that we'll definitely keep in mind as we're working on the new actions, and in particular in exposing agents as actions to other tools, other external tools. That's something we'll definitely keep in mind.
All right, last question of the day, which is a pretty hard one because it's a very, very new concept. What's your opinion on chain of draft as a roundabout for reasoning?
I don't know what chain of draft is.
Yeah, it's like I just searched on Google. It's like exactly a week old, the paper. So yeah, sorry, we haven't reached that.
I was off last week.
Yeah, that was skiing last week, so we can't answer. All right, thank you very much, everybody. Don't hesitate to join the Slack community. Let me put the slides back, and if I can remove that. I don't actually know how to remove it. Yeah, thanks a lot for being there. Thanks a lot for joining, and we'll see you in the next session. Thank you, everybody. Bye-bye.
Thank you.